All right, one more video on solving systems of equations, reviewing stuff that you learned back in Algebra 1. So in this situation, we're going to use the elimination method to solve a couple of systems of linear equations. So with the elimination method, basically what you're doing is you're taking the two equations and you're combining them. You're going to add them together. And when you do that, you're going to try to make one of the variables disappear. So anytime you've got two equations with two variables, the goal is to try and do something so that you can get it down to one equation with one variable, because then you can solve for that variable, plug it back in, do whatever you got to do. So with this elimination method, as I look at the two equations, I'm going to decide which variable I'm going to eliminate. What I want is I want to see the same coefficient with a different sign in front of one of the variables. Now, I can multiply equations by whatever I want as long as I'm fair and do everything on both sides. So what I might do is I might try and eliminate y. Well, I know that if I want to get rid of y, I have to try and make 2 and -3 match up somehow. Sometimes it's as easy as multiplying the two of them together. So if I were to say, hey, I'm going to multiply the top equation by 3, well, if I multiply everything in this equation by 3, that would give me 9x plus 6y is equal to 36. And then the second one, if I were to multiply everything here by 2, perhaps, what that would do is that would give me 8x minus 6y is equal to 66. So I've changed both of the equations, but again, I've changed both sides, so I just have an equivalent equation. If I graph these, they're going to be the exact same thing. Okay. Now for the elimination part, or the combination part. So I'm going to add the two equations together. If I add the x's, 9x plus 8x is going to be 17x. So just adding like terms. 6y minus 6y is going to be 0. That's the idea. It canceled the y, which is nice. So we've got nothing here, but on the right side, we've got 36 plus 66 is 102. So I'm going to take a two equation with two variables and turn it into one equation with one variable. So now I solve for x. I'll divide by 17, and x is going to be equal to 6. Okay. So 6 is the answer for x. Now to find y, I got to plug it back in. I can plug it back in to either one of these equations. It doesn't matter, whichever one looks easiest. So I'm going to go with the first one because there's positive numbers. So 3 times 6 plus 2 times y is equal to 12. Well, that's 18 plus 2y equals 12. Subtract 18 from both sides. That's going to give me 2y equals -6. And y is going to equal -3. So there's the y value. That would be my solution. So 6, -3 would be the ordered pair. And then I would probably just quickly check it in both just to make sure. Like if I plug in 6, -3, does it work in the other equation? Well, 4 times 6 is 24. -3 times -3 is 9. 24 plus 9 is 33. That's a solution. That's good. Okay. So we're going to then solve two others just so you see what answers might look like. Some weird stuff is going to happen in these next equations. Okay. A couple systems. That, erase this. All right, the one on the left. If I solve this system again using elimination, I'd look to get rid of, let's say, the y's again. So if I multiply the top by 2, that will give me 6x plus 4y equals 10. Now notice what the second one is. If I don't change it at all, it's -6x minus 4y equals positive 10. If I put those two together, 6x minus 6x is 0. There's nothing there. X is gone. 4y minus 4y is also 0. Nothing there is gone. No more variables left, which is kind of weird. On the other side, 10 plus 10 is going to be 20. So what I have is I have an equation. It doesn't really make any sense. I don't have any variables, and 0 does not equal 20. We have a false statement. So if you end up with variables, all the variables disappear, and you have a false statement left over, okay, if that's a false statement, that means that there is no solution to this particular system of equations, okay? Another thought here is that there's no solution. It means that these two linear equations never cross, so they must be parallel, okay? So just something to keep in mind. Not that you have to write that down for an answer or anything like that, but again, hey, if they don't ever cross, it must mean that they have the same slope and they must be parallel to each other. Now, the other thing that might happen as you solve these systems, another weird thing where variables disappear, check out this setup. So if I were to multiply the numerator by -3 to make the x's go away, I'll multiply this by -3. It's the numerator, which is the top equation. That gives me negative 9x minus 18y equals positive 30. And then the other one is going to be, I don't know why I did that with underlining it, 9x plus 18y equals negative 30. If I put these two things together, negative 9x plus 9x is 0. Negative 18y plus 18y also 0. 30 minus 30 also 0. So what I got is 0 equals 0. So variables disappear, but what I'm left with is a true statement in this case. So if I end up with a true statement, that means that there are infinitely many solutions. Okay? You wouldn't say all real numbers because that wouldn't be accurate. There's infinitely many solutions. What that means is that graphically speaking, these two equations represent the exact same line. So there's one line, and then the other line is right on top of it. So it's infinitely many solutions because any point that's on one line is a point on the other line as well. So anything is going to work as long as it works in one of them. There's an infinite number of those solutions as it goes off in both directions to infinity. So that's solving systems with elimination and a couple of the funky things that might happen along the way.